Hi guys, today is day 2 of finding the zeros by factoring. Before we discuss finding the zeros, I want to discuss the quadratic formula. When you have a quadratic in the form ax squared plus bx plus c, a is the term, a is the coefficient of the x squared term, b is the coefficient of the x term, and c is the constant. The quadratic formula is used to find the zeros by placing negative b plus minus the square root of b squared minus 4ac all over 2a. No x's, there are only the coefficients that we're using. When do we use the quadratic formula? Well, to be honest, we can use the quadratic formula on any quadratic. However, it's best used when the quadratic won't factor. So we use the quadratic formula when our quadratic does not factor. So today we're going to talk about the sum of cubes. So this is another type of factoring problem, but it follows a specific pattern. The sum of cubes. When you have a perfect cube plus a perfect cube. Now you know perfect cubes are, for instance, 2 times 2 times 2 is 8. 8 is called a perfect cube because it's something times itself 3 times. 3 times 3 times 3 is 27. 27 is a perfect cube because 3 to the third power is 27. So 27 is a perfect cube. To factor the sum of perfect cubes, we first rewrite the problem. We think to ourselves, what cubed would give us 8x cubed? And that would be 2x. 2x times 2x times 2x is 8x cubed. We rewrite the 27. We think to ourselves, what number cubed would give us 27? 3 cubed is 27. So in the pattern where they use a plus b, our a is actually the 2x and our b is the 3. So where they say a plus b, when we factor ours, it will be 2x plus 3. Where the pattern says a squared, we will do 2x times 2x, which is 4x squared, minus, where they multiply a and b together, we would multiply 2x times 3. That would give us 6x. They say put a plus, and b squared, b is 3, so 3 squared is 9, and that's factored. So it's very important to start out by rewriting their problem. Okay, I'm going to erase that so I have a little bit of room. And I want to talk about once we have it factored. Once we factor our polynomial, we set our factors equal to 0. So if we do that, set our factors equal to 0, we have 2x plus 3 equal to 0, and 4x squared minus 6x plus 9 equal to 0. So the first binomial, we can set that equal to 0 and solve for x. Minus 3, 2x equals negative 3. Divide by 2, x equals negative 3 halves. One of the x-intercepts is negative 3 halves. Now we come to the quadratic. Sadly, this quadratic will not factor. So when we have a quadratic that does not factor, we have to use the quadratic formula to solve it. So we're going to plug in the quadratic formula. Remember that a is the number in front of the x squared, b is the coefficient of the x, and c is the constant. So here we go. X equals negative b. So that would be negative 6 plus minus the square root of b squared, which is negative 6 squared, minus 4 times a times c. A is 4, c is 9, all over 2a. A is 4. We're going to work this out. X equals a negative negative 6 is a positive 6, plus minus the square root of 36 minus 144, because negative 6 squared is 36, and 4 times 4 times 9 is 144, all over 8. All right, we continue simplifying, and we get x equals 6 plus minus the square root of, that comes out to negative 108, all over 8. X equals 6 plus minus the square root of negative 108. I would break that down into a perfect square times the non-perfect square, like 36 times 3 is 108. I would put my negative with my perfect square because these two things are going to come out of the square root sign. I'll show you that in this step. So we have x equals, we have 6 plus minus the square root of, we take the square root of negative 36, which is 6i. Remember that the square root of negative is the I. We leave the 3 underneath the square root sign, all over 8. We simplify. If we can reduce these 3 numbers, we will always reduce them. So we reduce by 2, we get 3 plus minus 3i, square root of 3 over 4. And those would be 2 imaginary solutions. So recall that imaginary solutions on graph paper, we had one real solution at negative, negative 3/2, that's negative 1.5. And it's going to pass through that, and then it's going to make like a little dip, but not deep enough to cross the x-axis, because that would create two real roots. All right. The second problem that I have is the difference of cubes, but you do it the exact same way as the sum of cubes. You follow the formula to factor it. It's a minus b instead of a plus b, and it's a squared plus ab, and the other one is a squared minus ab, and then they're both plus b squared. So you can do that one on your own. The next one I wanted to show you guys is the difference of squares when you have a perfect square minus a perfect square. It factors into the square root of 25x squared, or in other words, what times itself gives you 25x squared. That would be 5x times 5x gives you 25x squared. And the last number times the last number has to give us a negative 16. So we have a positive 4 and a minus 4. So the difference of two perfect squares will always factor where you have the same exact binomial with a different sign in the middle. So we set our factors equal to 0, 5x plus 4 equals 0, 5x minus 4 equals 0, and we get x equals, it's always the opposite of the positive 4, divided by the 5. So this one would be the opposite of the negative 4, divided by the 5. Those are your two x-intercepts. So what we're doing today is finding x-intercepts, but using factoring. The last type of problem we're going to do is a factor by grouping. We know we're going to do factor by grouping when we have 4 terms. And we group the first 2, group the back 2. Group the first 2 terms, group the back 2 terms. We factor out a GCF in the first 2, which would be x squared. We have 3x minus 4 plus, we factor out the GCF in the back 2, which is a 3. We'll end up with 3x minus 4 in parentheses. Notice the binomial in parentheses is the same, and it should always be the same. If it's not, something went wrong. Now to finish it off, we group our two GCFs together. So our GCFs were x squared plus 3 times the common binomial 3x minus 4. And we only write the 3x minus 4 one time, and we are done. Now to find the zeros, we set our factors equal to 0 and solve for x. 3x minus 4 equals 0. Now we'll solve for x. So we'll subtract 3, x squared equals negative 3. Take the square root, always put plus minus in front. Well, anytime you have an x squared, you're always going to have two answers. So we have plus minus I square root of 3. Remember, when you take the square root of a negative, you take the I out. And over here, x will equal the opposite of this number, which is positive 4, divided by this number, 3. Those are the two x and, 3. Actually, there's only one real 0, so there's only one x-intercept. Again, this would look like something like this. It would cross at 1 1/3, and it would have a little, I always call it like a little whipping action, where it doesn't come deep enough to cross your x-axis again. There's one more factor by grouping problem that I wanted to show you, and it's when your third term is negative. When your third term is negative, you want to rewrite it with plus a negative 6x minus 15. So we group the first two, we group the back two, just like before. We factor out the GCF out of each set. So that would be x squared times 2x plus 5 plus factor out the GCF. This one you will always factor out a negative GCF. So it's going to be negative 3 times 2x plus 5. So you could distribute to make sure that you got your signs right. Negative 3 times 2x is negative 6x. Negative 3 times 5 is negative 15. We group our two GCFs together. So we have x squared minus 3 together times 2x plus 5. The common binomial is only written once. And we set each of those equal to 0. So we have x squared minus 3 equals 0, 2x plus 5 equals 0. Back to the left, we'll add 3, x squared equals 3, and square root, x equals plus minus the square root of 3. Those are two real solutions. Square root of 3 is 1.7, so we have positive 1.7 and negative 1.7 for x-intercepts. And the other binomial, we take the opposite of this number, which is negative 5, divided by 2. And our other real solution is negative 5/2. Thank you. I hope this helped.